Okay, lesson 23 and 24 is all about equivalent equations, the additive and multiplicative equality properties. And basically what the additive and multiplicative equality properties say is that if you add the same thing to both sides of the equation or multiply both sides of the equation by the same thing, you don't change the value of the equation. Before we get into this, we're going to use this in a little bit to solve some equations. Let's talk about equivalent equations. Now, equivalent equations are two equations that have the exact same solutions, and that's as in-depth as it gets. So, for instance, our first example here, we have x plus 6 equals 9 and x plus 10 equals 13. Now, it would be real easy to prove that 3 plus 6 equals 9 and 3 plus 10 equals 13. And since those are the only solutions for those equations, we say these are equivalent equations because every solution to this guy over here is a solution to this guy over here. Okay? Now, similarly, down here in example 1, we have 4 plus something equal 15. Well, it'd be real easy to prove that x has to be 11 here. And 7 plus x equals 18. Well, it'd be real easy to prove that that's 11 also. And when I say it'd be real easy to prove, all you have to do is take the 4 over here, subtract it, take the 7 over here, subtract it. 15 minus 4 is 11. 18 minus 7 is 11. So we see that these are equivalent equations because every answer to the top equation is an answer to the bottom equation. All right, well, let's take a look at number 2. And I have the work sort of halfway done here because this is our first example where we're going to find that they're not equivalent equations. And I wanted to make sure that we got a good description here. 13 minus 2x equals 4. Well, the first thing we're going to do is solve this for x. So I have it recopied over here. And the first thing I did was brought the 13 over here, and I'm going to subtract it. We got 4 minus 13, which is negative 9. The only thing that's left on this side of the equation now is negative 2x. So I would have to divide by this negative 2 to get the x by itself. So divide by negative 2. And we find out that x on this side is the weird fraction of negative 9/2. Well, whenever we look at the bottom equation here, something plus 4 equals 7, we really don't even have to do any rearranging to figure out that x has to be 3 here. 3 isn't the same thing as negative 9 over, or 9/2. Negative 9 over negative 2 are just regular 9/2. So these two are not equivalent equations because they don't have the same solutions. Let's move on. Let's look at number 3. We have 34 minus x equals 8. Let's see. Well, first thing I'm going to do, I'm going to bring the 34 to this side and subtract. I have 8 minus 34, which is 26, negative 26. So that means negative x equals negative 26. So we drop the negative signs. X is 26. Wonder if x is 26 over here. So first thing we're going to do is add or subtract 2 from here. Subtract 2. So we have 2x equals 62 minus 2, or just 60. And something times 2 equals 60. We know x here is 30. Those are not going to be equivalent equations because here x is 30, here x is 26. Let's look at number 4. We have 8x plus 2 equal 26. X plus 1 equals 4. Let's do this one first. What plus 1 equals 4? Well, x has to be 3 down here. So for these to be equivalent, this x up here has to be a 3. So why don't we go ahead and just take this 3, plug it in, and see if it works. So 8 times 3 plus 2 equals 26. Maybe. 8 times 3 is 24. 24 plus 2. Yep, this one checks out. So these two are equivalent equations. Now down below here, we have some more complicated simplifications. We'll try these ones together in class. Now, before we move on, go ahead and put an equal sign and a 1 after this top equation in number 6, because without that, we don't have an equation. I don't know why that didn't copy through, but that should be there. Okay? Now, let's move on to the back and start talking about the additive property of equality. All the additive property equality says, like I said before, is if you add the same thing to both sides of an equation, you don't change the value. Let's start with something like this, 2 equals 2. And what we're going to do is we're going to add 4 to both sides. So 2 plus 4 is 6. And we're going to do that to both sides. And notice that my equation is still the same on both sides, just bigger numbers now. That just means we're allowed to add the same thing to both sides. And that's really helpful in solving equations. For instance, x plus 8 equals 21. Well, what I need to do is get this 8 out of here. And in its essence, I'm going to add it to both sides to move it away from the x over to the 21. Maybe an easier thought is when I take it from this side, bring it over here, I just change the sign. So we have x equals 21 minus 8. 21 minus 8 is 13. So x in this case has to be 13. Let's look at number 2, another easy one. 9 plus something equals 17. Notice it's a positive 9, so when I bring it to the other side, it has to be negative. And then x has to be 17 minus 9, or 8. Now, before we try to solve for the variable, sometimes we have to do some simplifications. Like in number 3, we have to put these numbers together before we try to simplify here. Or I'm sorry, before we try to solve for the x, we have to simplify first. So 14 plus 2 plus 4, that's an easy 20, plus x equal 24. Now notice I didn't change the equation at all. All I did was take 14 plus 2 plus 4 and turn it into a 20. Now I'm going to do the same thing I was doing up above. Go away from the variable, subtract the 20. When I bring it to the other side, 24 minus 20, and x is 4. One last example before we move to the back and try the multiplicative property of equality. We'll do 4 plus 2. Remember, simplify first, and then move away from the variable. So here we'll have 19 minus 6 on the right, which is 13. And the only thing that's left is y, so y has to be 13. We'll try these last 4 examples in class. Okay? Now, let's move to the 3rd page, which talks about the multiplicative property of equality, which says the exact same thing as the additive property of equality, only now we're using multiplication. We're going to start with the same exact thing, 2 equal 2. That's my equation, and I'm going to multiply both sides by 4. So 2 times 4, 2 times 4, I get 8 equals 8. And we can see that multiplying both sides by the same number doesn't change anything. And we're going to use that to solve some equations. So here we go. We have 6x equal 12. Notice that I'm multiplying by 6. I'm going to move to the other side and do the opposite operation, which is divide. 12 divided by 6 is 2. That means x equal to 2. Number 2 says 14 equal to 2x plus 4. Now we're getting into some two-step problems, and here we have to recall our order of operations, and whenever we're undoing an equation, we have to use reverse order of operations. So instead of multiplying and dividing first, when I'm undoing the equation, I have to add or subtract first. So 14 minus 4 is 10. And that's equal to whatever's left over here that I didn't move, which is 2x. So 10 equals 2x. Now I'm going to use my multiplicative property of equality, and I'm going to divide both sides by 2, or move the 2 over and do the opposite operation. Since I ran out of room, I'll move up here. X is equal to 5. Okay? For the time being, we're going to skip number 3, go to number 4. Notice that we have some simplification to do before I try to solve this. X plus x plus x, that is 3x, and then plus 10 equals 25. First thing I'm going to do is move the 10 over, subtract it. I have 3x is equal to 25 minus 10, or 15. And then I'm going to bring this 3 over here and divide by 3. There's my arrow. 15 divided by 3 is 5, and since I ran out of room, I'll move up here. And in number 4, x is 5. And we'll try the rest of these in class. Now, if there was anything that was confusing to you, remember this video will be online. Go ahead back and watch it, especially the parts that you found to be a little confusing. And that is all we have for lessons 23. and 24.